This is where we left off last time. Only you can't see it. This was example 9 out of the book, and we got two planes intersect at a line, right? And Seth and I did the 3-pencil deal, you remember? And I opined that if I want to find a point, I need a point that is on this line. And if I want a point, any point, I just let z be equal to 0. Could let x or y be equal to 0. And then I have two equations in terms of x and y. And then what I did is I solved those simultaneously, and I found an x value and a y value. And that gave me a point that is not only on both of the vectors, but it's also on the line of intersection. Now I have a point, and remember I said I think of slope in vectors as the normal vector, the orthogonal vector, the perpendicular vector. And the way you get any one of those, in particular the normal vector, is the cross product, right? So what you would do is you'd cross those two vectors. And you would get a vector u, and then you would use that vector with this point, and you know how to write it in parametric form because we work problems like that. And it's explained pretty well in the book, and I would like to stop there on this problem. If I can do that, then here's my plan. I have the final exam with me, so I can talk to you about the final exam today. And I need to show you how to integrate a vector and how to differentiate a vector, and that's all. And I have a meeting Friday morning at 7:30 that I don't know will be over by 8. And what I would like to do, if I can finish today, is make today the last class period. And that'll give you some time to get caught up on homework and to get ready for the final. And the reason I can do that is you've been taking your tests in the test center, right? So you gave me a couple of extra class periods that sometimes I need and sometimes I don't. If I can finish these today, I will have done everything that I need to do to get you ready for Dr. Freelove. And I can give you back, you've had 4 tests in the final, that's 5 class periods extra. I can give you back 2 of them at a time when you probably need them the most, right? So, shall we try to do that?
Sounds good.
Okay.
Is this going to be a test question on the test on Monday, Tuesday?
Yeah. This will be a test question. Yeah. I'm going to read them off to you in a minute. The good thing about this test, both for you and me, is there no long problems on this test. There are, all the problems on this test are sort of like this. You just have to remember how to do it, or put it on your card so you know how to do it. Okay. Here's another test question. This is example 10. That's right, William, that's right. I need to talk to you about the final exam, don't I? I'm going to tell you today about test 4, but you probably would like it if I went over what was going to be on the final exam, huh? Mm-hmm. So, suppose I go ahead and give you Friday off, and suppose on Monday we meet to talk about what's on the final, for nothing else, for what's on the final. And then we'll just go, because I don't have anything else that I need to cover. How about that? Okay. And if you don't want to come, you don't have to. I'll tell you now, the final looks, there's nothing on the final that wasn't on all of the tests. So there's no surprises. But if you want to come and want me to hold the final in my hand and tell you what it looks like, I do not mind doing that. Byers, do you have both of you, do y'all have other classes?
Yeah.
On Monday? How about we'll have the camera on Monday? And if I have to tell Beth what's going to be on the final, I'll do it, and I'll get Ms. Hardy to post it out there. I'll do that for you, and none of you will have to come. Have any of you not been to the videos?
I've looked for them, but I can't find them.
Yeah, I haven't found them.
Don't you go? Who uses YouTube a lot? Did any of you? Or all of you?
Yeah, we probably use it quite a bit, all of us.
Well, don't you go there and can't you search me?
You do have some videos on there, but it's like...
Or tell me there was no dancing girls involved.
There's like...
there was no dancing girls and no handcuffs, right?
Yeah, I don't know if it was that... Who's his name who filmed you a while ago?
Paul.
But I wasn't able to find any of these newer ones. Did y'all give me emails the first day of class? Y'all gave me an email where I could contact you?
I think so.
What about, like, when you write it down, you just say there's going to be a question that asks, can't you just write what the question is and not put the actual problems? Could you do that on a piece of note? Like, you just say the questions asked, parameterize this, and it's going to be 2f of x's or something like that.
Yeah, I might try. I'll work on that. I'll do you right. By now, I hope you trust me that I'm going to do you right. I'm going to treat you right on this. Number one, I'm going to find a way for you to find those videos. That's number one. Then number two is, and I will look for an announcement on Course Compass that says how to get to the videos.
Okay.
How about that? And then number two is, what I might try is taking the problems off of the test and just let you look at the directions. That's what isn't that what I read to you anyhow? Mm-hmm. And truly, I don't care if you know the directions in advance. If you can work, there are 19 problems, I think, on that test, one of every different kind of these. if you can do all 19 of them after I've told you what to look for, suits me fine. Okay? All right. One way or the other, I'm going to tell you about this test, and then I'll send you something on the final exam. And all joking aside, I might just set the camera up in my office, talk about it on the camera, and get Ms. Hardy to post it. And I might send you an email with just the directions for the test. But I'll do you right. Okay. If I don't quit talking, we're going to meet anyhow. So this is example 10 on page 711. We've got a line we got a line. Does everybody agree that's a line in parametric form? And this line would you agree that if the tabletop's a plane and this is a line, regardless of where, regardless of what angle and all of that, it intersects it at one point? Agreed? And we want to find the point. And here is the giveaway question. If I've got a line there and I've got a plane, every point on that plane has to satisfy that at every point, there has to be a point on that plane that the line satisfies. Do you agree? If I just knew the t value of that point, I could get the x, y, and z values from the parametric equations, huh? So what if I took the equation of this line, substituted x, y, and z into the equation of the plane? Then I would have an equation all in terms of what variable?
T.
T. I solve for t, and doesn't that tell me the t value that will give me 1 point on that line that intersects the plane? Okay? I don't feel like I have to do it, but I got time to do it. So I'm going to substitute the line into the plane to find the point of intersection. So I have 3 times 8/3, well, you know, I'm not going to say it. 12t minus 4t, is 8t. And 8 plus 6 is 14. And 8t, I don't like that. 8t is equal to minus 8. T is equal to minus 1. A negative t is okay. You remember in movies as they're counting down, t minus 10, t minus 9, t minus 8, So now I know what my t value is, and all I do is to find the point. To find the point, I would substitute t equal minus 1 in equation of the line. So I get x is equal to 8/3 minus 2. Is that 8/3 minus 6/3, which is 2/3? Y is equal to minus 2 times 2, which is times minus 1, which is 2. And z is equal to 1 minus 1, which is 0. So the point is, would you like for me to put 2 or 3 of those on the test?
Yeah.
Questions, anybody? Okay. I need to do 2 more here. And that is, I want to find the distance. This is example 11, page 711, number 11. I need to find the distance between S, which is 1, 1, 3, and the plane. I've got tabletop's the plane. I got a point up here, and I want to know the perpendicular distance. Perpendicular means cross product, doesn't it? Isn't that what it means? So what I want to do is again, I got a point right here. I need another point. I need any point on this plane. Say, here's a little dent I'll use. I'm going to say I got this point way back here, and I've got this right here. And I'm going to form a right triangle. My elbow going down to the tabletop, right? And I want the distance from my pointer finger on my right hand to the top of the table along a perpendicular line. Everybody agree? And that would be Isn't that what we were talking about? This is the tabletop. This was the point this was the point, and I need to find this. I need to find any point on that plane. Any point on that plane. And remember, all math teachers are what? Lazy, that's right. I want any point on that plane. Meaning I can pick any value I want for two of the variables and find the third one, right? By substituting in. Agreed? What they did is they said, fine, I'll let x be equal to 0, I'll let z be equal to 0. That I said pick any value, right? And remember, pick easy ones. So look at the equation. If x is 0, z is 0, doesn't that mean 2y is equal to 6? So y is equal to 3? And look down there. Do you see that point P that appeared right there? That's what we did. Does everybody understand what we did? I needed any point, so I just made it easy. Okay? So now what I'm going to do is, you tell me, here's what I want you to think, but you don't have to, you're going to have this written on your card. But here's what I want you to think. What is this? Oh, it tells you what that is. What is that?
The normal vector.
The normal vector. You can tell it's perpendicular. It is one of many normal vectors, right? Normal vectors shoot up from this tabletop everywhere, don't they? But I needed one in particular that goes through that point so I could make a right triangle. So there's my normal vector, and it's going to go through that point, So that means I can find this particular vector. Then I can find this vector, right? And I'm going to call this U and this V. And now what I'm going to do, watch. I'm going to project U onto N or V, whichever one you want it to be. And you're going to have written on your card, you're going to remember how to do a projection, aren't you? Everybody follow what I did, what I'm doing? Got it? But what that shakes down to is the distance D is equal to absolute value, right? Distance has to be positive. If you don't put the absolute value, I won't care as long as if you get a negative distance, as long as you tell me it's positive. Okay? So I have PS times N over. Now tell me in words, what's that?
Sign or absolute value, or the N over the absolute value?
That's the vector N divided by its magnitude, right? But what is that? Unit vector. And unit vectors give you what?
Direction.
Direction. So all I'm saying is is the distance. I'm gonna take PS, and instead of having it go in this direction, I'm gonna have it go in this direction. I just took that and projected it over to here. Okay? That's the way I remember it to this day. This is the original vector V, and I'm going to use that. I'm going to use that vector, but instead of letting it go at this angle, I'm going to let it go at 90 degrees. And that's all there is to it. So let's see. I need that normal vector. So let's write out how we do this. First thing I'm going to do is I'm going to find the vector PS, because I know I'm going to need it. Is that, let's see, that's 1 minus 1. So that's 1I. And then, 1 minus 0, and 1 minus 3 is minus 2j. And then, I did that minus that, okay. And then 3 minus 0 is 3k. Did I do that right?
Yes.
All I'm doing is I'm subtracting. I want PS, I usually start with the second one. So I did 1 minus 0, 1 minus 3, and 3 minus 0. I think I got that right. Okay? So I know half of it already, huh? Now I need the vector, the normal vector in. Any suggestions? Well, number one, they give it to you, huh? How nice of them. How do I get the normal vector in without lifting my pencil?
That just in without the absolute value? Or?
How do you define a plane?
3 points.
What does it take to define a plane?
3 points or 2 lines.
Louder.
3 points or 2 lines.
3 points or 2 lines. And if you have 3 points, you can get 2 lines, right? Then you get those 2 lines, and then what do? Remember I said that to me this is one of the strangest things in mathematics? How does that guy hold that trowel with his putty in it? He's got a handle on it. And that handle determines how it's tilted, right? So to define a plane, we need a normal vector for that plane. But in order to do that, I need 2 lines on the plane so I can cross them, right? So look what they did. They found another point on there. But this time they let y and z be equal to 0, and they got this point. Then they needed one more point so they could get 2 lines, right? And they let x and y be equal to 0, and they got this point. So now I got 3 lines on this plane, huh? Is that right? Then I cross these. I cross them. I form this vector. Then I form this vector, and then I cross them, and that gets me in, doesn't it? Everybody agree? So let's do it. Let's say that V1 is equal to, I'm going to say 2I minus K. Is that right? What I'm doing is do you agree? I did this minus that one. 2 minus 0 is, whoops, what did I do? 2 minus 0 is 2I, 0 minus 0 is 0, and 0 minus 1 is minus 1. Everybody agree? And I'm going to do the same thing here. And that's how I would form V2. But V2 is going to be equal to 0I, 3J, and then minus K. Do you agree? And you can cross them. The thing of it is, here's the thing of it. You don't need to cross them. Why? That's the normal vector for the plane. Do you remember that? And where does the 6 come from? Any point on the plane. You put any point on the plane for X, Y, and Z, any point on the plane, and that will give you the right-hand side. And we did that last time. I gave you a couple of ways to define a plane, huh? But the coefficients of X, Y, and Z in the plane are always the normal vector. Always. And the right-hand side is by putting any point. Let's try 2, 0, 0. Will that yield 6 on the right side? Yes or no? X equal 2, Y equals 0, Z equals 0. 2, 0, 0. When you substitute that in, do you get 6 on the right side?
3.
3 times 2 is 6. 0 and 0. I just picked this point, William. This point's on the plane. And I just picked that and substituted it in. So the way you get an equation of the plane is take any point on the plane, find the normal vector. You create the left side with the normal vector, and you get the right side by substituting any point on the plane in for X, Y, and Z.
I know I talked about this yesterday, but what if you pick a point that's not on the plane?
Not on the plane or on the plane?
Like, you know, it's like you pick Z as 0. Is there going to be, like, what if there's not 1 0 where Z is on the plane?
That was on that last problem.
Yeah.
I needed any point on that plane. So out of the air, I picked, that was for 2 planes intersecting, right? Mm-hmm. I just needed a point, at any point, huh? So I just let z be equal to 0, and then I found two equations with the other two in it. See, look, let me go back to this one. Not that one, but that one. I have two equations. Do you see two equations up there? In three unknowns. That's a no-no. You can't solve two equations in three unknowns. You need it to match. You need a 2 and a 2. I said, fine, I'll pick a value for one of them, and I picked the easy one. So I'll let z be equal to 0, and when I let z be equal to 0, this equation became this, didn't it? Mm-hmm. And when I let z be equal to 0, the second equation became this. Whoops. That's the first equation.
Second
let's
one.
see, I solved for x, and then here is the second equation. 2x plus y.
Which is, you see it's over there.
Huh?
It's just over there to the right, yeah.
Right up, and it came from right up here.
Mm-hmm.
Okay? All right? Back to the problem at hand. So I know that n, the normal vector, is equal to 3i plus 2j plus 6k. If you have time, after a while, do V1 cross V2 and see what you get. You'll get that, but what you'll get, by the way. Okay. Now, let's see. Now I need n. I need the magnitude of that, don't I? So the magnitude of that is the square root of 9 plus 4 plus 36, which is the square root of 49, which is 7. So now the distance, so let's see, now the unit vector n over the magnitude of n is equal to 3/7 I plus 2/7 j plus 6/7 k. And that's a unit vector. If you don't believe me, take the magnitude of it and see if it's 1. Okay? Now, don't I now have both parts? So all I do is cross them. No, I dot them. I don't cross them, I dot them. Okay? So now I have, do it black, I have I minus 2j plus 3k dot 3/7 I plus 2/7 j plus 6/7 k. So I now have dot products, first times first, second times second, third times third, and add them together, right? So I think that is 3/7 sevenths, minus 4 sevenths, plus 18 sevenths. That's 21. 18 and 3 is 21, minus 4 is 17 sevenths. And that's the distance we were looking for. Pretty cool. Questions? Any questions? Let me show you a giveaway, another giveaway problem on test 4. The test 4 is a good chance for you to get healed, if you know what I mean. This is example 12 on page 712. Two planes. Two planes, 3 minus 6, 2. Whoa, 2. 3 minus 6, 2, and 2, 1 minus 2. Okay. All right. I want to find the angle between the two planes. Everybody agree that those two planes intersect at a line? Everybody agree? And everybody also agree that I know the normal vector for each of those planes right now? All I have to do is just write it down. Okay, then look at this. Page 712. I want you to look at that and tell me, Seth and I think, Seth, we'd have to have more help if we tried to do this, because that's 2 pieces of paper and 2 pencils. And we were having a hard enough time the other day with what was it, 2 pieces of paper? No, it was 3 pencils, huh? We made 3 pencils look pretty hard. But imagine that we were doing the same deal Seth and I were doing the other day. What I want to convince you of is here's 2 planes, and here's the angle between the 2 of them, right? But I don't know how to find the angle between 2 planes, but I don't have to, because if I know if I've got 2 planes, that intersect at some funny angle, and I've got, imagine that I've got a unit vector, a normal vector coming out of here, and a normal vector coming out of here. What I want you to notice is that, I didn't have to do it like this, is that those two normal vectors, the angle between those two vectors is exactly the same angle as between the two planes. Follow? Okay? So, what that means is this. I know vector n1 is equal to 3i minus 6j minus 2k. And I know that vector n2 is equal to 2i plus j minus 2k. I know that, right? Well, that's really nice because the angle in between the two planes is the angle in between the two normal vectors, as we talked. And one of the first things I showed you about vectors is remember that? Where theta is the angle between the two. Okay? So, can you find cosine theta equal to some number? Don't you just do the dot product and find the length of each one? And that number is going to be in radians. And then you do the inverse and you get the angle. And that problem is completed in the book. I don't think you want me to go through all that again. You know how to do a dot product and you know how to find the length of each, huh? Okay? All right. Everybody okay with that? I want to do 13.1, section 13.1 only. Are you shocked? Would it shock you if I were to tell you that we're going to do it my way as opposed to the book's way? Here's what I want you to notice. Fill in the blank.
Plane.
Agreed? is that?
A spiral.
It is indeed. It is. I bet Ms. Voss is even too young to know about a slinky. Do you know about a slinky? Well, that was a compliment to say you were too young, huh? Anybody else know about slinkies? That's a slinky. That's what that is. It most definitely is not a plane. And what I want you to notice is, let's see, this is 726. There's my slinky, the blue line. I substituted t equals 0. And let's see, if t is equal to 0, don't I get the cosine of 0 is 1, the sine of 0 is 0, and whoops. That's one way to do it. And just 0 there, huh? So don't I get to point 1, 0, 0 right there? Now if t is equal to pi over 2, we're making it light on ourselves, right? I could have picked 2 if t is equal to 2, but then you'd have to use a calculator, right? So I'm going to pick at t equal pi over 2. Is that 1? Is that 1.57? 3.14 divided by 2? So at t equal 1.57, it's all right to talk about what happens at 1.57 seconds after something, right? Cosine of pi over 2 is 0. The sine of pi over 2 is 1. And that's pi over 2, right? Pi over 2k. And if you put those in, you will get that point right there. Then if you put in pi, you go from here to here to here to here, and then you just keep on going. Everybody see what we're doing? My point is, what is the difference? Everybody but Dr. Thomas and Ms. Voss, what is the difference between the first equation that you told me was a plane and the second equation that you told me was a curve? Let's just call it a curve.
It looks like a cylinder.
Yeah, it all happens inside the cylinder. But what's the difference between the two? One is a plane, one is a non-plane, huh? What causes it to be a non-plane?
Curve.
Look at the coefficients of x, y, and z. In the first one, the coefficients are what? Numbers, right? So if the coefficients are numbers, you get a plane. Constants. If the coefficients are functions of t, you get a curve, and you can get some doozies. But those curves are exactly what you're going to want to know about. I love to use the Golden Gate Bridge when I'm talking to engineers. But now do you see that you can describe the arc on those steel strands. And you can describe that arc by that vector right there. But not that vector, but that family of, huh? You follow? Okay? Now, here's my question. Suppose for a minute that I wanted to find, suppose for a moment that I wanted to find right here. Suppose right here I wanted to find instantaneous rate of change. Suppose at this very point, imagine again, look up here, imagine the steel strands that balance the Golden Gate Bridge. I want to know when it's in the middle of this arc, I want to know what the instantaneous rate of change is. You get the idea? And aren't you going to use things like that in stress and strengthened materials and so on? So, aren't y'all the class I had for Cal 1? No, Miss Hardy had you. I had you, didn't I, William? And everybody, and you had Miss Hardy. And, but in Cal 1, you learned what instantaneous rate of change was, right? What is it?
Derivative?
Yeah, the first derivative, huh? And to find the instantaneous rate of change at a point, what do you do?
Get the derivative
Take
and
the
plug the
derivative,
point.
plug
You
in.
plug it in, huh? You plug it in. Okay, well, I'm going to need to find, suppose I want to find r prime of t. You want to tell me what to do? How do you take derivatives?
One term at a time.
One term at a time. So this looks to me like minus sine t I plus cosine t j plus k. And that's the way I take derivative. And the first derivative is the velocity. The absolute value of the first derivative is what?
Speed.
Speed. When you take absolute value, don't you take direction out of it? And doesn't absolute value take direction out of it? And the second derivative, could I find another derivative if I wanted to? Absolutely. Second derivative is what?
Acceleration?
Acceleration. So do you get the idea, Ed?
That's applying to zero acceleration.
Do what?
Is that when you take the second derivative, it's implying that you just have uniform motion in the plane.
Exactly. 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 If you know your acceleration is zero, doesn't that mean that it's staying at the same speed? And sometimes that's important to know, isn't it? Get the idea? Okay, let's see.
You know, in classical mechanics, we had a whole chapter on that. Spiral motion.
Really? I think I just covered that chapter, didn't I, Ed?
What was that? What the weird deal is about classical mechanics, there's only one formula per chapter. Like Lagrangian in one, Hamiltonian in the other. I forgot, we were doing something with spirals and motion. They got pretty elaborate.
Okay? Let's see. So suppose I want to find then, the slope of the tangent line at pi over 2. Well, isn't that then r prime of pi over 2? Isn't that the way you did it in Cal 1? Which is minus the sine of pi over 2 times I plus the cosine of pi over 2 times j plus. Ed, what did I put in front of the caddy?
A 1.
Yeah, I leave it alone, right? Am I not on the left putting pi over 2 in the place of t every time I have a t? But I don't have one, do I? So I just leave that k right there. Everybody agree? So now I have, this is then sine of pi over 2 is what?
1.
1. The cosine of pi over 2 is 0. So don't I have minus I plus k is the velocity vector at pi over 2. That's the velocity vector. But I want to know the exact velocity. How do I find it? How do you find force? In force, isn't force the magnitude of a vector? Is that right? Find velocity the same way. So what I'm telling you is that the velocity at pi over 2 is equal to everybody agree? And isn't that then the square root of 1 plus 1? Do you agree? Which is equal to the square root of 2.
Now, the square root of 2 would be the speed, right? The velocity, you'd have to specify a vector. Or even the...
Yeah, the velocity, yeah. I'll say that this is the speed, and the velocity vector gives you both speed and what?
Direction.
Direction. Make sense? Okay. Pretty cool, isn't it? So that's all I want you to know. That's all I want you to know. All I'm interested in your knowing is, I want you to know that when you got constants, you get a plane. When you got anything else, you get a curve, and usually they're a doozy too. But you can do just like you did in Cal 1 and find the velocity vector. You can find the first derivative and then you can find and that and then you put in the point, and you can find the speed and the direction, huh? So the speed is square root of 2, and it is in the direction of the vector -1, 0, 1. Do you agree? It's in that direction. So, let's see, -1, 0, 1 it's going to be a line sort of like, let me get it again, -1, 0, 0, 1. -1's back here, right? -1, 0, 1. So it's going to be like that. -1 is about here. 0 is about here, and 1 is about there. About like, let me get it again.
Is this like the centripetal acceleration or something?
No, what I'm telling you, that is the direction of the instantaneous rate of change, huh? Is that right? Right? And in particular, at the point t equal, what did I do? Did I do pi over 2?
Mm-hmm.
That gives me -1 is back there. -1 is back there. 0 is right there. And 1 is up here. There it is. And that gives me this vector, which is the tangent line. Okay? Questions? Ed?
I want to bring something up. If you're planning to go into civil engineering or mechanical engineering, the parts you have to worry about moving parts, it would help, whatever 4-year school you go to take the classical mechanics course at the graduate level. Because what it'll do, it's not cookbook stuff like what you have in statics. It's more conceptual kind of things.
Good.
And like, for example, you can set up systems of weights and pulleys, and then to the Hamiltonian on it, gives you all the equations of motion. It's pretty neat.
Problem on the test is going to be like the first 14 problems